much faster the optics was you were talking about compared to a tactile measurement process? How much quicker can it be?
Really, really quick. We still have stage movement, so we've still got to physically move from one side to the other. Now, some of the machines can be fitted with linear motors for speed. If you've got large stage movement, they will move a lot quicker than a CMM.
Hello and welcome to another MTD podcast. I'm Paul Jones, the Managing Director and founder of MTD CNC. Today's podcast is coming from the Fulham Group, a business based, I think we're in Foxton in Derbyshire. That would be correct.
That's absolutely correct.
I know it's about 15 miles from the train station anyway, because that's how I managed to get here before. And actually on that point, joining me on today's podcast, I have two gentlemen, the first of which Rowan from MTD CNC, who brought me kindly here.
Yeah, thank you, Paul. You're welcome for the lift, Paul.
That's good. Yeah, I didn't pay you, did I? Or did I?
Not yet.
Okay, so still owed. And secondly, Graham Shaw, who's the sales manager for OGP and VICIVISION, a part of the Fulham Group. Graham, welcome to the podcast.
Thank you, Paul. Thank you. Nice to be here.
And now what we're going to talk about today is, actually, I've learned so much today, and I thought that was really one of the reasons I wanted to do this podcast as well, is because there is so much to talk about when it comes to OGP and VICIVISION. It's an area of within our industry which I don't look at that commonly, but it's certainly got a place. And boy, what we're going to talk about today is optical inspection. Very, very flexible measurement of components using the optics laser and styluses as well, all combined. And this is really what's fascinating certainly about the OGP product. And then VICIVISION for shaft measurement. Just to start with then, Graham, but just sort of introduce OGP. Let's start there.
Okay.
What the business is and what it does and where you sell plant or kit to.
Sure. As I've mentioned on previous discussions, OGP was formed in 1946 from the production side of things, really to supply 2D optical equipment to the likes of Kodak in America. That's where it really started from. From that, it got developed into a multi-sensor system in 1976 to where we are today with multiple sensors on the machine. As we like to claim, one sensor fits all.
And Rowan, have you seen any of these machines?
I've not. I've seen walking around kind of trade shows and whatnot. I've seen kind of components sat on. They're quite kind of like clear plastic beds and then some lasers shine. That's all I've seen. That's all I know about these. So systems. Your
experience in inspection, have you had much?
So I've done a bit of using just a standard CMM like a Mitutoyo CMM, and obviously manual inspection with calipers and mics and whatnot, but never anything as complicated as kind of non-contact inspection.
I noticed you use the word complicated. They're not complicated.
Okay, well,
do you know what? I was going to pick him up on that as well. I thought, I almost learned to use one this morning.
Yeah. Did you?
That simple. But
that's funny because I learned to use a Zola preset this morning.
And that's for another podcast, which is coming to the MTD channel soon as well. Graham, let's talk then about this optical. Where would you use optical measurement?
I think if you've got components where...
And what it is.
Okay. So as I explained earlier on some other videos I did, when I have a challenge by going around a company, and you might deal with a managing director, a production engineer, a quality engineer, that have a bottleneck, for instance, in inspection. It could be shop floor measurement, it could be an inspection room. And they may have traditional technology, they may have coordinate measuring machines, but I can guarantee you'll come to the inspection room and there'll be boxes of turn components, mill components, sat outside the room, waiting to go into inspection, which is a challenge then for the managing director, because all he wants to do is get the product out the door to his customer so he can invoice, so he can get paid. Where the benefits of optical equipment are, that the more optics you can use, the quicker the measurement's going to be. So, for instance, CMM technology, you mentioned Mitutoyo. If you're going to be probing on a Mitutoyo machine, and most CMMs are probably 2 seconds per point, an optical measure machine will take 150 points in half a second. So you're going to get a vast throughput of measurement. Now, optical machines are not for every business case you look at, because there may be other features on there that you can't physically look by camera and measure. So this is when we introduce other sensors, such as probing capability or laser capability, into one system.
So the 2 seconds of point is because it's going to happen to make contact with that point and then log when it made contact.
Correct, absolutely.
And then going to the next point. So it's 2 seconds. But the optical, do you have to have 150 cameras to do 150 points?
No, one camera and a moving stage. So sort of a frame of a CMM with a camera being the main sensor, and then probing capability on there as well. On top of that, by using optics, then your fixturing side of it is not quite as expensive
because there's no contact.
There's no contact. So yes, the component has to be, it can't move and slide around on the bed of the machine, but you don't necessarily need high sophisticated fixturing to hold the component.
But what about, is there not a situation where something gets in between the camera and the part, which would, essentially make the process not reliable?
If for any reason there's an obstruction for the first thing, so the camera cannot see what it needs to measure, it will come up and say, I can't find the part, the edge is not clearly there, or we can't focus on the part. Unlike a CMM, you can't crash it in the Z-axis of a machine by a camera. It's got a trip on the camera as it comes down. CMM, you can actually damage quite a few probe styli if it collides into a particular workpiece. Now, I'm not saying that we don't have that challenge, because we do if we're using probing as well as. But again, go back to the more optics I use, the less chance I've got of collision, and the quicker the measurement's going to be.
So if someone's got a part with complex features on two different faces which are opposite to each other, do you have to place it in one orientation, take it out, and put it in another orientation?
There's that particular way of doing it, or you can introduce a fourth axis and a fifth axis. So you can still rotate around the component all the way around as we've done today, very easily on the machine.
And you got to see this machine out there, Rowan. It blew me away, the amount of features on it and what it's capable of. What was that model that you were talking about?
That's a Vantage 450 with dual rotary capability.
So is that a driven rotary table then?
Yeah, a true fourth axis. So it carries its axis system around upon rotation. So it's really, I suppose, the same as having a coordinate measure machine with an automated head on there to get into different features that would spin around to access it. Yeah,
right.
Yeah.
So are there rotary encoders inside the rotary table? That
yes, correct. To maintain its position. Yeah.
And then that particular machine, what other methods of measurement is on it? Because it's not just the optics, is it?
No, obviously I mentioned about tactile touch probe, but we've also got a laser on there, an inframetric laser. Now with a laser, when you're looking at the profile of a surface, you might have some features on there you need to scan. And there are different types of lasers within the industry that you can use, such as line stripe lasers or a straight down laser, which is the inframetric one that we use on ours. It has a very large working distance, and that can be up to 200 millimetres in depth for maybe scanning at the bottom of a bore. You might have a manufactured part with a blind hole in it, but you want to look right down at the bottom to see how the shape is at the bottom. Well, you can't put light down there. You possibly can't probe it because it may just be a small hole, a blind hole that you're looking down, hence using a laser then to get right to the bottom.
So can that laser angle in loads of different orientations to access all sides?
It can angle around. If you typically look at, let's say, a sphere, you can get halfway around the sphere with a laser. So you're going over that particular surface. It's not 100% the perfect solution, but if you imagine that somebody's gone down a bore and cut into the bottom of the bore, you're going to see basically the drill end of it being measured right at the bottom.
So you've got to measure the right at the bottom.
Right at the bottom, yeah. Yeah.
And how many companies would look at what we're just talking about and go, well, I don't need all those different methods of measuring, compared to how many companies would look at it and go, if I have that, my possibilities are endless? Because it's two different mindsets, isn't it?
There is. As I mentioned earlier, as we've been discussing things, if you go to a company, you might see 4 pieces of metrology equipment that are doing different tasks. So, yes, you might have one doing cylindrical components. You might have one looking down bores. You might have one as a roundness machine. You might have one looking at a surface of a machine. You might have a CMM. So there must be multiple machines. This particular machine fits all. As far as one machine, so you've got one calibration to be concerned about every year, and different sensors, all working on the same unit.
So I guess when you've got one machine, you need to rely on it to be quick enough that that doesn't then become a bottleneck, because it provides all that functionality.
Absolutely, yeah.
There is only one area, and I don't like to talk about negatives, but it's always important to look at two sides to it. If you did have those 4 different pieces of equipment, you could do 4 different parts at the same time, couldn't you? It's like the argument between having one vertical machining center or one multitasking machine versus 4 vertical machining centers. If you've got 4 spindles, you can make 4 parts at once.
Correct.
So there is a bit of a trade-off there.
It depends how you look at the trade-off, because you might need 4 different specialists to use 4 different pieces of equipment, where one system you need 1 specialist as such. So there's you could say, well, actually we're going to get things done quicker. Now the way I always look at this is when you're trying to not going to use this incorrectly, replace staff, you're going to allow staff then to go and do other jobs that they're probably better time spent than working on 4 different pieces of equipment. And that's the beauty of having optics, probe, laser all in one particular unit. You have one expert, 2 or 3 users of it, and it's going to be much quicker then to get parts measured.
And I couldn't believe how much faster the optics was you were talking about compared to a tactile measurement process.
Yeah.
How much quicker can it be?
Really, really quick. We still have stage movement, so we've still got to physically move from one side to the other. Now, some of the machines can be fitted with linear motors for speed if you've got large stage movement. But in fairness, they're fairly rapid movement-wise anyway. They will move a lot quicker than a CMM.
What about part cleanliness as well, though? So obviously, if a part's got a piece of dust on it, like with a presetter, you have to kind of dab it off with a piece of blue tack. How do you handle that kind of problem?
Well, it's the same as a CMM, because if you're measuring anything on a CMM with a, let's say, a Renishaw ruby, really that ruby should be clean every time you use it. Now, a lot of companies don't. They just carry on and use it. They calibrate the probes daily, but they should be clean, and so should be the part. Now, when you're using optics, you've got the ability to filter data. So we might look at an edge, and we might look at how that edge is performed. So we might be looking at a diameter, for instance, and you would then see if you've got ingress in the diameter. But our software is capable of ignoring the ingress and just giving you the true measurement. So it's sort of filtering the dirt out.
What do you mean by ingress?
So that could be swarf. It could be a hair. It's just a little anomaly in there. That's just when you're looking at it by a camera, it's picked up.
So you're handling those little bits of.
Yeah, absolutely handling it. Yeah.
What about the consumable cost? What happens if something happens to the camera? Is it more expensive to repair?
Well, believe it or not, these are not massive megapixel cameras that we actually use, within the machines, because we're purely using them for edge detection. So they're not a high-cost camera that are easily replaceable. I've got to say, with the 550 plus machines we've got installed, we don't change many cameras. We do things like Windows updates, as you do, and sometimes controller systems need updating every now and again, but not cameras. They are pretty reliable cameras.
And I always thought, and a point I mentioned to you on the videos, and by the way, people listening to this podcast, if you want to watch the reviews on these particular products that we're touching on, you can on the MTD CNC website. There's 4 or 5 actual videos about OGP and some of the product reviews that we're talking about. I mentioned, Graham, that I think your customer, if you have one of these machines, would dearly love you to have one, because you can see what investment you're making in to make sure that you're delivering them the correct part.
Absolutely.
That must be an important point in your sales process.
Very, very important. So what we try and do with all of our customers when we supply a piece of equipment is hold the hand through the process. Should they want program generation, that's a part of what we offer to customers as well. Ideas are, if they do need to hold the part, maybe because of multiple rotations, we'll advise them on fixturing as well. We support machines now through the internet, through things like TeamViewer, and Teams meetings as such. So we can assist programming if required. But the machines are relatively easy to program anyway. But it's just if the customer needs a handheld in all the way through those early stages of a machine going in.
Because this might be the first time they've looked at any kind of part inspection, and they need that throughput, but because they never want to start inspecting because it takes a long time. And like you said, the MD's looking at this massive pile of boxes that they want to just get out. Yeah. It's about making sure the parts are right, though.
It is. Most important for us is to making sure that when the machine goes in, they're programmed correctly with education. Take them through that process. Tell them the challenges that they may be faced with. So let's talk about a bright aluminium component. And with that component, and if a machine, unlike a CMM, is sat next to a window, then you could get ambient light comes through a window, shines on top of an bright aluminium part, and that then could reflect in the results that you're getting. But built into the machine are lighting conditions we can impose on the machine as well. So it will automatically change the light according to
based on the ambient.
Based on the ambient, yeah, which gives a great advantage to all of our competitors in doing that.
Do you ever see any resistance from where you put an optical inspection system in, where there's previously been just a CMM or something? Do you ever get resistance from people who have been using the CMMs and they say, I don't know how this camera can be any better than my Ruby Pro?
I'll be honest, all the years I've been in business now and selling measuring equipment, you always have those challenges. You'll always get the person that says, well, I've just measured it on my micrometer. It's completely different to what you guys are getting. And then we have to go through that process of proving that what we're actually measuring is correct. Now, it may be that obviously we're measuring a diameter, but we are averaging the diameter out, whereas a mic must be just going a straightforward distance. 2 points. So we have to prove to them that it's absolutely bang on.
Because what you're doing is what he would be doing if they went and measured every point along that diameter and then averaged.
Yeah, I can always remember a challenge, and I've got to bring this challenge into the conversation. I was at a company once, and I can't mention the name, but the challenge was, I've got my operator here who's been measuring these parts now for 5 years, and he's going to measure these with a micrometer. Your challenge is, you've got to beat him on your optical measure machine. And this was purely optics, that's all it was. So we set the challenge, the clock was ticking, more or less bang on time, we both said we finished. So the managing director said to me, well, it's just as quick as you. Why do I want to invest in your machine? We then said, put your next part on. So the 5 minutes became 30 seconds. And that's where the benefits are then. And he could then fully see why I was trying to sell him an optical measuring machine.
Did you sell him one?
Yes.
Yeah. The just for going almost back to basics in some ways, for those listening to this thinking, well, why don't I just inspect the part on the machine during the process? What is the advantage to doing it off the machine? Albeit it might sound obvious, but worth explaining.
I suppose it's different down to the manufacturing process and what customers are trying to achieve from their manufacturing process. There's a lot of things we can actually do by getting more information. We can more than likely do than what you can actually do on the actual machine tool itself by the use of optics and by use of laser. We can certainly give more precise data from the product, by taking it offline as such. Now, there is, again, as we're working through robot integration, there's the ability to put a part on a machine tool, manufacture it, move it by a robot onto an optical device, back on the machine tool. There's all things that we can integrate within OGP machines as well.
Yeah, it's been a real eye-opener today for me, Graham, looking at the OGP product. We've been talking for over 15 minutes already, so I want to get into VICIVISION, which, again, optical measurement, which is the theme of this podcast. Can you explain the VICIVISION product and what it actually does?
Yeah. So the VICIVISION product measures cylindrical components and non-cylindrical components with telecentric optics by really checking the outside profile of the actual component to start off with. And it will then do rotational scans to give you things like run out. So it's sort of a 3D, 2D type optical system that can measure small pins, less than a millimetre, up to 240 millimetres in diameter, and an overall length up to 1250 in overall length. So there's a good selection of machines available for different industries.
Sat vertically, shafts vertically. In a vertical plane, quite good to see in action. But the big market for me, I thought, was the sliding head technology.
100%, yeah. And we've put quite a lot of these machines in at sliding head companies now. And they've been really, really successful. We also have, which we will be launching at Mac, a high-resolution version of a machine. So if you've got pins that are less than 1 mil, but very small rads on there, you do need a high-resolution machine to see some of these fine details that you just can't measure by conventional methods. And that will be launched at Mac.
Yeah, I remember I went to a sliding head place up in Dundee, and they were making absolutely minuscule little round parts, and I guess those would be perfect for inspection because there's no way you can measure those rads, or you can measure even on the bores on the inside. You could EDM it out, and I guess if you EDM'd a bit of it out, you could inspect the bore in the system.
I don't want to confuse anybody. If you're looking at VICIVISION, it's really external features.
Right.
You do have the ability to put a probe on there now as well, a tactile measurement, but it will still not do internals.
Right. Okay.
This is when you've got to look at the other technology to do internals. It really is external features on the VICIVISION machine.
What about a shaft with a pocket and a couple
shaft,
of balls?
Shaft with a pocket in, shaft with a through hole in.
Yeah.
No problem at all.
So flats and holes
Yeah,
and whatnot.
a shaft with slots in, not a problem at all.
So how were they measuring them, Rowan?
They had a vertical optical system, but I don't think they knew how to use it, unfortunately. I can't remember whose it was, but I remember they had it sat there, and there was someone sat there with some plug gauges and some verniers doing it themselves. Don't know why, but yeah.
I mean, yeah, how else would you measure a longer part to make sure from one end to the other, and how do you do that without something like this?
You could CMM it, you could put it on a coordinate measure machine and do it that way, but then when you're checking in thread detail, so we have a thread database and we can quickly measure a thread on a part very, very quickly and accurately.
Otherwise, you need some. I've seen some people have some special ground teeth where they can measure the pitch diameter, the major diameter, but it's all quite complicated and quite cumbersome.
It is, and time consuming, more importantly.
Yeah.
I mean, as you see during the presentations we've done, we had a component on there that's probably measuring 30, 40 different features, 30 seconds. You know, it's given all the data you require from that particular part.
I guess the time investment is programming making sure the program's right, making sure the reporting is right. It's not the measurement in the middle that's the problem.
Well, you say that, but there's two ways of programming. One is what's called self-programming mode. So all you need to do is say, I'm going to start here, I'm going to finish here, measure it for me. And it will select every feature that's possible to measure from the component it sees. Then you'll have to go and put your tolerance in. But you've got a basis of a program.
So you haven't got to tell it where it will just
measure everything. You've got to teach it, start and finish, and then select, the sort of features you're looking to measure, and it will do it automatically for you. The other method is to get a traditional drawing or a DXF CAD file and program from the CAD file or from the drawing. But it's not time consuming, because you've got to remember it's a 2D type system. So it's very, very quick and very, very simple.
All you've got to worry about is your length and your diameter.
Your length and your diameter, correct, yeah.
Is there an assurance certificate or something that it would send to the customer, and it's all part of the system?
Absolutely, yeah. So with both products, VICIVISION and OGP, what we tend to do from a reporting point of view, we can put data into a database. So when the customer's looking for traceability on a batch or a machine that's produced the part, they can go into the software, they can look at all the results over a period of time and then give the data out that's electronically recorded. So it's not like you and I possibly making a mistake by typing something into a spreadsheet. It's done automatically.
Rowan used to sign other people's names on his route cards.
If I had route cards at all, yeah.
God, that's probably before your time, is it, route cards?
Yeah, well, a little bit, yeah.
Before we, almost 25 minutes into this now, Graham, there's once again, I have to say, if you go to the MTD CNC website, if you want to watch some of the product reviews on VICIVISION or OGP, there is plenty there, so you can actually not just hear about it, you can see them in action as well. Of course, both of these all fit beautifully under the Carr-Fullen group, don't they?
Absolutely. Yeah.
Why does it work so well? I
think from our point of view, from the Carr-Fullen group itself, we go from design, 3D printers, into manufacture, being Zolla, and then obviously the inspection part of it is OGP and VICIVISION. It's a perfect fit for, I suppose, a group of engineering companies under one umbrella as such, to promote what we can do for businesses.
Can you measure Rowan's output?
It's going to be challenging.
It's hard to measure zero, isn't it?
On that point, but I know actually, I'll tell you what, we are going to, just before we go, there was a story you were talking about earlier about how you, there was a couple of things that you measure.
Yeah, that's correct. Yeah.
That people could probably liken and associate.
I suppose when you look at difficult challenges and some of the challenges that we've been faced with over time. So if we're looking at, let's say, an aeroplane and looking at engine efficiency and getting more out of an aeroplane for saving of fuel. So if you look at things like a nozzle guide vane that's got cooling holes, in that particular product, they're very, very difficult, almost impossible to use a coordinate measure machine to measure them. Yes, you can put pins in. Yes, you can measure the pin themselves to find out the position, but it doesn't tell you an awful lot about what's happening to the cooling hole. Use optics and the right kind of lighting, and we can measure those successfully. And then on the flip side, we have medical, that we do a lot of work in medical. And if you imagine somebody that's suffering with asthma, that's going to take an inhaler to get a drug into their body, there's going to be a small hole that the drug is delivered through. Now, that hole might be 20 microns, it might be 10 microns to get the drug through, but they have to be measured because the wrong amount of drug going into your body could obviously cause a problem. And this is where, by using optics...
You've got no chance of getting a probe in
you can't get a probe into a 20 micron hole now. No.
wrong amount of drug going into your body. That also happens to Rowan on a Saturday night.
Oh, you're walking to the station, Paul.
Gentlemen, it's been a real pleasure. Really enjoyed it. Visit the MTD CNC website to see some of the reviews I've done with Graham on some of these OGP and VICIVISION products. Alternatively, you can obviously visit the Carl Fulham Group website or come and see them here in Foxton. It's a really impressive facility. Thank you very much, gentlemen. Thanks for your time. It's been another MTD podcast.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.